Greetings and welcome to a lesson on functions, for loops, and while loops. Now, I know that sounds like a lot of material to cover in a single week, but it's really not. Remember, we already know the theory behind all of these things. We've already dealt with the theory of functions or methods, for loops, and while loops. The only thing we need to learn is what is C++'s specific way of doing these things and any language-specific details that we need to know, like this nonsense right here. So let's get down to it. For the moment, we're going to ignore these lines, and I want to go straight to how do you define a function in C++. In C++, a function definition has a data type, function name, and parameter list. All C++ functions must have a return data type. Now, if that data type is nothing, as in the function is not actually expected to return data after it has been called, you still have to define it as having the data type void. You don't need a return statement. I mean, you can put a return statement in. It is perfectly syntactically legal to write return like that with a semicolon and nothing after it, but it is not mandatory. You'll notice I'm not getting any syntax errors here saying that this is invalid. If you have a non-void data type, then you must have a return statement that returns out the appropriate data. Function names follow the same rules as variable names, alphanumeric, and the first character must either be a letter or an underscore. It is tradition, but not syntactically required, for functions to use upper camel case for capitalizing the letters in the function. A function does not have to have parameters, but you still have to have the parentheses regardless. So in the case of this never called function here, I have an empty set of open close parentheses, but addStuff does have parameters, so I have a comma separated list of parameters. C++ is a strongly typed language. That means your parameters must have a data type as well as a variable name. So we have addStuff with int a, int b, addStuff with float a, float b. Talk about that in a moment. And then find some that is int target. Calling a function, again, pretty standard. We've seen this before. I have the function name. I have my open and close parentheses, regardless of whether or not there's parameters. Remember, a function must always have its parentheses if you are calling the function. And then if there are parameters to be passed in, passing in the parameters separated out by commas. Now, let's take a look at these lines up here. These are called function prototypes. And something very interesting happens if I comment these out. And I try to run my code. There are build errors. No, I do not want to continue. addStuff, identifier not found. Now, if your only programming experience is with Python or Java, you might be very, very confused right now. Because addStuff most certainly is defined. Well, C++ is very strict about order. You must define something before you can use it, and that includes functions. So since I am trying to call the function here, but the function isn't defined until down here, C++ is like, yeah, no. By the time I reach this line in the code, add stuff has not been defined, so I have no idea what you're talking about. This is where function prototypes come into play. By having this prototype here, I am informing the compiler, hey, compiler, I'm not defining how it's going to work yet, but I'm letting you know that I am going to define this function here. And now with this prototype in place, if I run my code, now it runs, and I get the correct output. There is another scenario in which you will see prototypes, but we will deal with that next week, and that's with header files, which is a very, very important part of C++ programming. But again, we'll push header files off to next week. For now, know that in C++, you have to define the function before you can use it. Now, why do I have two functions called add stuff, and why is it not complaining? Well, other languages also have this. You will see this a bit more frequently in C++, and especially C code, because C and C++ lack some of the language features that more modern languages have, and that makes function overloading more common. For example, for adding two values together, well, it makes sense that I'd want to add integers together, but what if I also want to add floating points? Oops, I need an F there to tell it that those are explicitly single precision floating points and not double precision floating points. What if I want to add in floating points? Well, decimals, floatings, are not integers, so I might want to have a version of adding that takes floats. But I don't want to have add stuff integer in add stuff float. I just want to be able to call add stuff and have the function figure out which version to call on its own. This is function overloading. And how it works is a function has what is called a signature, and that is the function name and its parameter list. As long as the function signature is different, you are okay. So, signature on this one is 2 floats. Signature on this one is 2 ints. That's fine. They're different. This one's commented out, partially because I don't have the function implemented, but also because this is not a valid overload. And so you can see immediately I get red squiggles of doom yelling at me, cannot overload functions distinguished by return type alone. The signature on line 8 is the exact same as the signature on line 7. That makes it an invalid overload. Now, if I change this to, say, this, that is fine. Of course, now it's complaining because there's no definition for it. But as far as being a potential function, this is fine because the signature is now different. This is int float, which would be perfectly acceptable. So that's why I've got 2 versions of add stuff here. Something else I want to call your attention to is my prototype of find sum. Here I have int find sum int a. Okay? But then down here where I actually define the function, I have int find sum int target. The variable names don't matter, both in terms of signatures and in terms of prototypes. What matters is that I have an int find sum and I pass a single int into the parameters. Int find sum single int as parameter. That's what matters. The fact that the variable name between the definition and the prototype is different is utterly irrelevant. Does not matter. Okay, now that we've taken a look at functions, let's take a look at our while loops and for loops. While loop is pretty simple. We use the while keyword. We have a set of parentheses, and then whatever is inside the parentheses has to evaluate to be true or false. Something to keep in mind for C++, and this is very specifically C and C++. That is perfectly syntactically correct. In C and C++, a Boolean value is just simply a number. 0 is false. Any non-zero number is true. And actually, underneath the hood, the names true and false are just simply defined as 1 and 0 for false. Don't, by the way, do something like this. Use the keywords true and false. It makes for much more readable code. So we have while, some statement that can evaluate to true or false, a curly bracket to define the start of the while loop, and a curly bracket to define the end of it. Again, Visual Studio will use this line here to help you visualize the scope of the while loop. And then the actual code. Remember, the indentation that I have here is irrelevant. I could have my indentation look like this, and my code would run just fine. Pay attention to your indentation, though. One of the first things your instructor will typically ask you to do, if you come to get assistance and your indentation looks like this, is you will be asked to fix your indentation so that everything is indented to the correct levels, so to speak. So everything that belongs to the while loop is indented one level past the line that the while loop's on. Everything that belongs to this if statement is indented in one level, so on and so forth. Syntactically, is it necessary? No, it is not. But again, this is far more readable code than this. Oops. Did too many Control-Z's there. Other than that, the while loop functions the same as it does in most other languages. As long as this condition is true, it will execute the loop, and it will check this condition every single time it comes back up before it does an execution of the loop. It is possible to never execute the loop, not even a single time, if this condition is false from the start. So if I change continue to false here, and I run my code, it just doesn't do the while loop. Let's take a look at for loops. Now, if you've done the Java class, this will look very familiar. C++ loops are the same as Java loops, or would be more correct to say Java loops are the same as C++ loops, because Java came quite a bit after C++. The general syntax is we have the for keyword, open and close set of parentheses, and then we have 3 statements inside here separated out by semicolons. We have our initialization statement. We have our before execution Boolean check. And we have our end of loop statement. How this works is when you hit the for loop, this statement will be evaluated before you do anything else in the for loop. This can be any valid line of code. If it is something that I could put on its own independent line, it can go in here. Traditionally, this will be initializing a variable that only has scope within the for loop. So int I equals 0 if you're preparing to do an array iteration, or in this case, int I equals 1, because, well, it doesn't make any sense to start from 0 when I'm doing a sum. Next, you are going to have your loop condition check. Before any code is executed for the for loop, you are going to check to make sure that this evaluates to be true. It is possible to have a for loop that will never run even once if this is false from the start. For example, if I make my I value something very silly, and I run my code here, and I say find the sum of 10, it's going to tell me the sum of 1 to 10 is 0, which is obviously not correct. That's because 1,000 is not less than or equal to 10, and so the for loop never executes. Finally, you have your end of loop statement. Once all the code has finished executing in your for loop, but before we do this check, we are going to execute this line of code, or this statement, I should say. Again, anything that can be a line of code is completely acceptable to put here. 17-stage equation, function calls, whatever it is, you can put it here. So a way of thinking of this, it's not 100% correct, but it's a good way of thinking of it. When you hit this curly bracket, you are going to check to see if this is true. When you hit this curly bracket, you are going to execute this statement. So when you first hit the for loop, you will do this statement. Then you'll hit the curly bracket, check to see if this is true. It is. Execute whatever code is inside here. You hit this curly bracket, indicating that you're at the end of the for loop. You'll execute this statement, and then you'll go back up here. We're now here. Okay, is this still true? Yes, it is. Loop, 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 until this is not true, and we break out of the loop and continue on with program execution. And so to go over exactly what this is doing, ignoring this because this is obviously just calling the function call. So I'm initializing my continue value to true. I'm saying while continue, which currently is true. Initializing value to 0, and then I'm going to prompt the user to give me a number. Find the sum of what? Enter 0 to quit. And then I'm going to use cin to grab input from the user and store it in value. Again, remember we are not sanity checking any of our inputs right now, so make sure you put in a number. And then I'm going to check. Now, I did say enter 0 to quit, but I am checking to see if value is less than or equal to 0. So it just doesn't make sense to try to do a sum for a negative number. Like -5, no, that just doesn't make sense. So as long as it's 0 or less, I'm going to set continue to false. Otherwise, I am going to print out this line. Notice I have a function call in the middle of here. I'm going to say cout this string, the whatever value was given in from the user, the string is, and then I just got a function call right in the middle here. That's perfectly acceptable. The only rule is that whatever part is here that's being fed into the arrows, so to speak, just needs to evaluate to be a value that can be sent to the stream. That's it. That's the only rule. So since this is going to evaluate to be a number, yep, that'll work. And so we'll call the function, figure out what it is, and send it on its way. And then I've got two indel statements, one to basically do the next line, and then the other to put in a space. So when I run the code it looks like this. So find the sum of what? I want to find the sum of 6, 21, 7, 28, 8, 36. And then finally I can enter 0 to quit. But notice I've got a gap in between each of these. I could have also done this on its own line, but it just felt it worked best just putting in 2 indels here. And that is it. That is functions, for loops, and while loops. Pretty simple. So let's talk about the assignment. Factorial. I like factorials. They make very good assignments if you haven't noticed. So again, as a reminder, factorial is basically the number multiplied down to 1. So 3 factorial is 3 times 2 times 1. So for this assignment, the factorial must be calculated in a function. You are not allowed to calculate the factorial in main. It has to be done in a function. The function must use a loop to calculate the factorial. While loops and for loops will both work for this. I don't care which you use, but the function has to use a loop to calculate the factorial. In main, you're going to prompt the user to enter a number, and then you will pass that number on to the function. And you are going to loop in main, prompting the user, displaying factorial, until the user enters a 0. So your sample output might look something like this. Enter a number, 3, 3 factorial is 6. Enter a number, 4, 4 factorial is 24. Enter a number, 0, and the program ends. Of course, feel free to remove the hello world out of your main. And remember, while it should already be configured to work correctly, remember that whichever file you have selected is the project that is going to run. So again, I recommend when you start work on the assignment, close the lecture.cpp file. Make sure that you're on main and give it a quick run to make sure it says hello world before you start doing your assignment. The code must be in main.cpp. It cannot be in lecture. And with that, good luck on the assignment, and I'll catch you on the next one.